Okay guys, so now we're going to try a different example. We have what's known as a combustion reaction. In particular, we have C7H12 reacting with O2 to produce what is known as carbon dioxide and water. Okay, so what we have to do now is we have to figure out how to go about balancing this reaction, because it's not balanced at the moment. You actually only have one carbon on the right and you have 7 on the left. So you can clearly see that it's not balanced. The way you should approach this is the way you should approach any problem. The last two elements you always want to balance are hydrogen and then oxygen. You can choose to do as many elements as you want in the beginning, but the last two you're always going to analyze are hydrogen and then oxygen. Make sure to try and follow that rule. So, how many carbons do we have on the left? Well, if I look on the left side of my chemical reaction, I see that I have 7, a subscript of 7. So I have 7 carbons on the right, on the left, I apologize. How many do we have on the right? Well, I have my invisible 1 here, so I know that I only have 1 carbon on the left, on the right. How many hydrogens do I have on the left? I have 12 hydrogens, so I'll make sure to make a note of that. How many hydrogens do I have on the right side? Well, I have a little 2 here, so that must mean that I have 2 hydrogens. How many oxygens do I have on the left? I have 2. And now here's a bit of a tricky question. You got to be careful with this. How many oxygens do I have on the right side? Well, it's actually a combination of these 2 oxygens plus this other oxygen here. So what I do is I make sure to make a note that I have a total of 3, but in parentheses, I put that it's a 2 plus 1 format. And this will become important later on, and I'll demonstrate to you why you definitely should put how you came up with your total of 3. Okay, so we start looking at our chemical reaction, and we realize that we're imbalanced as far as carbon. We have 7 on the left, but only 1 on the right. So how do we begin to correct this? We do what we've been doing. We add a coefficient. We come here to the carbon. We go ahead and add a coefficient of, in this particular case, what number times 1 will give you a total of 7? Well, it would have to be 7 times 1. So 7 times the coefficient of 1 gives you a total of 7 carbons, so that's balanced. Now, you cannot forget, as soon as you apply a coefficient, that number is going to apply to both the first element and the second element. We have to distribute that coefficient. So now it's going to be 7 times 2 oxygens to give you a total of 14 oxygens. Notice how it changed it here, and now I'm going to go ahead and change my total. I'm going to change my total from a 3 to currently 15. I'm not going to worry about this though, because I always analyze these one by one, starting with carbon, and then I go to hydrogen. We'll worry about that in the end. Next thing I look at is the fact that I have 12 hydrogens on the left, but I only have 2 on the right. So how am I going to go ahead and correct that? I go to where hydrogen is in my reaction. I see that I have a subscript of 2. So what number times 2 will give me a total of 12? It must be a coefficient of 6. So if I put 6 times 2, that'll give me 12 hydrogens. The next thing I have to do is I have to make sure I distribute that coefficient. So the next thing is this 6 times the invisible coefficient of 1 would give me a total of 6 oxygens, plus the 14 from before gives you a brand new total of 20 oxygens. Now all you have to do is balance the oxygens, because you can see that the hydrogens are balanced. All we have left is the oxygen. I have 20 on the right, I only have 2 on the left. So what coefficient am I going to have to add to this oxygen in order to balance this? Well, it's going to be some number times 2 to give me a total of 20. So it'd have to be a coefficient of 10. 10 times 2 gives me a total of 20 oxygens. Again, if you ever have any blank spaces, you always want to make sure to add a 1. Just in case the question STEM asks you for the sum of all the coefficients, you want to make sure you add a 1, because if not, you would get 10 plus 7, 17, 23, but that's not the correct answer. The correct answer would actually be 24. This would be the sum of all the coefficients. So this is how you should approach balancing equations. The last 2 elements you always want to do are hydrogen and oxygen. If you follow this method, it's a pretty good method. You can't go wrong. Thank you.